Hi, I'm making a roguelike, specifically one that involves petting animals to become stronger and with a focus on exploration. In this world, loot refers to food, plants, and environmental data that animals need in order for you to rescue them. But the problem is I'm not a programmer. I can't code, I don't want to code, and turns out I didn't need to code to make any of this. For those unfamiliar, Unreal Engine has a system called Blueprints. It's a visual scripting tool that lets you code by connecting nodes and might be more suited for a designer or an artist to start prototyping their games. There have been plenty of games made with some amount of blueprints, usually for prototyping quickly.
使ったところですが、企画さんがまず、ゲームのフロー構成だったり
or so that designers can carry on testing without waiting on code from the programmers.
We use blueprints mainly for our UI, and then all of our characters and all of our items and everything like that. And being able to do all these things without relying too much on developers, that's a big plus for us.
And sometimes, blueprints are converted to C++ down the line for optimization. I plan to make my game entirely out of blueprints. When creating a blueprint, there's many common templates we can use as a foundation. There's the actor, which is basically any object you can place in the world. But since we want to make the player, we'll use the character class. These blueprint classes are basically foundations that can hold a bunch of pre-built or custom components. Here's the viewport to visualize your blueprint. And this is the event graph, where the magic happens. These are nodes. The red ones are event nodes, which are used to fire off a command. And the blue ones are functions, which are the commands. You can then connect a chain of function nodes one after the other from these events. Here, the begin play node fires off at the beginning of play, printing hello to the top of the screen, repositioning the player location to 000, and after a delay, destroying the player. Unreal comes with many pre-built nodes, but we can also create our own custom events and functions. There is a lot more to it and it can get quite complex, but that comes with experience as you learn over time about all the nodes that are available to you in Unreal. So first thing I wanted to test was movement. How does that work in Unreal for a 2D game? Well, a character blueprint comes with a movement component. You simply right-click on the event graph and search for the add movement input function. To activate this function, we can use two red event nodes to do either horizontal or vertical movement. I've added some stuff to mine for directional animations. And here we can see the side-by-side of the nodes firing off and the resulting movement on the left. Unreal is mostly associated with 3D games, and people primarily use Unity, Godot, or several others for 2D games, as did I for many years, but I recently switched over, and to me it simply comes down to choosing an engine that gives you the best tools to do what you need for your particular game. Now for the art, I've decided to go with 4 directions of animations in my game. Since 8 directions is not as feasible for most solo devs, and I don't want to overscope my game. To create these animations, Unreal has a component called a paper flipbook, which we can add to our blueprint. Like its namesake, it works by going through a bunch of sprites, frame by frame, to make it look like it's animating. To create a unique style, I came up with my own color palette and then made sure animals and enemies have simple but consistent designs. And to really make them shine, I gave creatures a pseudo 3D look by having them twist and turn. Also, I hand drew a ton of frames for the animations so it looks super smooth. Next thing we need is depth. A 2D game is flat, so everything is on the same flat plane. But objects being in front and behind each other gives it much needed depth. Unreal doesn't have any built-in 2D depth system though, so we'll have to make our own depth component. Like the built-in movement component, we can create our own custom components that can be put on any actor, so we don't have to repeat copy-pasting code for each actor. And any change to the main depth component will affect all blueprints that have it. To achieve depth, we take the y-axis value and add it to the z value, meaning as you go up, you go backwards in the z-axis, and as you go down, you get closer to the camera. It's simple but effective. It's also possible to do this with a shader for optimization purposes. So here it is for you to screenshot if you want, but I won't go into too much detail about shaders today. Even AI can be achieved through blueprints in a similar but slightly different environment called the behavior tree, which is also node-based. And luckily for me, I tested it early on because I learned that navigation does not work on the traditional 2D plane, which is why I had to rotate my whole game by 270 or -90 degrees. And that's where I learned an important lesson: to test all my core features first, especially in an unknown environment of using a new game engine. Then to implement the AI, it does get a little too complicated and deserves its own devlog. But for now, all we need to know that it's all possible with just blueprints. So, for now, here's a bunch of chickens following the player. The next core feature is petting animals. Petting animals out in the wild gives you access to weapons and passives based on those animals. And each animal presents a unique set of choices. Now, to keep all this data, we'll create an Unreal asset called a data table to store any information, and we'll reference this in-game the moment we need it. So far, there hasn't been any need to open up the hacker screen and use C++ to do even relatively complex tasks. Part of learning blueprints though is iteration. In typical roguelite fashion, I want to present interesting choices for the player so they can decide how to become stronger. These choices are kept in a loot pool to select from. To prevent two choices being the same, I needed to temporarily exclude items when a chip selects them. Initially, I would plug them out of the main loot pool and add them back after the final chip. Then I would save it to the file. Then I learned about local variables in Unreal and the fact that they are basically refreshed every time a function is called. So instead of temporarily removing from the original loot pool, I created a local variable to act as a proxy and handle the removal there instead, so there's no more saving required. Iteration is so important for game design, especially when prototyping. Prototype fast, but leave room so that down the line you can come back, optimize, and improve any element of your game. Here's another example. I initially used this method of getting a random array item. Then I found out that Unreal actually has a built-in node to get those random items. As a beginner, I had no idea, but the messy way got the job done, and it was no issue changing these nodes later on. Nowadays, whenever I'm using a new feature, I type its name into blueprints, for example the array, and see what nodes are available for me to use. Now of course, blueprints has its limitations and things you should be aware of using sparingly. This video by Shirt goes over some of these things in depth. Blueprints gives you the tools to do most anything you want. AI, saving and loading, procedural generation, and I even built a 2D tile editor in a 3D engine, so anything's possible. Ultimately, I made this video to show that the barrier to entry for making games is lower than ever. And if you don't want to code, that doesn't have to stop you from making games. If y'all are interested in some kind of in-depth tutorial that you can follow along with, let me know in the comments or like the video so that I know that people want it. In the next devlog, we'll look in depth at how a combat works in a 2D game. Thanks for watching. Bye bye.